Hey everybody, Lars here. Time for the second review video for Big Bad Unit 3. And in this video, we're going to go over something called file I/O. And when I say I/O, I'm talking about input and output, actually using files, durable stores on your hard drive for your data to read from them and then later on to write out to them afterward. Because if you think about it, when you save a program, you're taking your logic or what you're doing with the program and you're saving it in a file. Why wouldn't you do the same thing with your data? You know? So the first thing I usually do when I shoot this video is I tell the story about what happened when I went to school back in the dinosaur days. I went to college at St. John's University in New York, and I went for computer science, and they hadn't really wrapped their head around how to do computer science yet. You took an intro course. You learned your first language. I think the one I had in college was Pascal. I had already knew a couple of languages. I was lucky. I had a father and an uncle in IT when I was growing up. But anyway, so I had my intro class in Pascal. Then you had a data structures course. You're going to get a little bit of exposure to data structures at the end of this course. And after that, it was the Wild West. Okay? They just gave you a ton of courses with different languages, like I took Fortran and PL1 and COBOL and a whole bunch of different languages. And they didn't really have a set class for just discrete mathematics yet. They gave you probability and statistics courses at the math college and a bunch of different things. And instead of computer architecture, you took like a logical design course and you learned about electronics and you did some other things like that. So they had the way we do things now is better foundationally, I think, because we have our own discrete math course where we do set theory and graph theory and induction and proof by induction and things like that. And we have our computer architecture course where you learn what's going on, how to put together these computers and why they work the way they work, memory organization and things like that. But one of the byproducts of being taught the way I was taught and learning a bazillion different languages was that after a while you abstracted out what was important to learn when you were learning a computer language. Like you thought, okay, time for a new language. I need to know how to handle data. I need to know how to handle lists. We call them arrays. I need to know how to handle functions, and I need to know blah, blah, blah. So you learned what the important things to wrap your head around were. And one of them that we never went over in all of these classes was file I/O, and I thought it was strange because it's incredibly important. When you go out in the real world and your boss walks into your office, he or she is never going to say, hey, give me the first 500 Fibonacci numbers. Do 1 through 20 factorial. I mean, it's never going to happen. Okay, they're going to give you a file with data in it. It could be a comma-separated value file. It could be an Excel spreadsheet. It could be just data, regular flat data in a file. Okay? So when you're using a programming language, you should have an idea, at least a little bit of an idea, how to read in data and how to use it and then how to write it out. Okay? And we're going to do something simple today, but later you're going to learn that you could read it in and read in Excel spreadsheets. You could read from a database. You could do a whole bunch of different things when you're reading in your data. I just want you to get the feel for your data is going to be coming from somewhere. It's not going to be embedded in your little toy program that you use when you learn. It's not going to be created in a loop really quick when your program starts. You're going to be reading it in from a file. So I always promised myself, at least in my head, that if I became a CS instructor, that I was going to do file I/O. So I'm basically keeping a promise to myself that I made many, many years ago. So what I did was I have some code whipped up for us already, where I just go over the very basics of file I/O with sequential, what we would call sequential character file I/O. I'm just going to open a file and read it character by character. Boom, 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 down the line. Now, if you could see, do I have this in the right directory? I do not. I have a directory called Python Data Science, and you can see all the different years I've been teaching this. Fall 2018, and you see I have all my little programs in here that I've been using with our videos, and you can see this one that we're doing right now is not called Funks, it's called File Stuff. But I also have a file in there with some data called small e22. And what small e22 is, you can look down there, it has a whole bunch of names in double quotes separated by a comma. So it's what we would call a comma separated value file, or a CSV. And basically what this is, it's called E22 because it's from Euler 22. The problem with Euler 22 is a big file with a whole bunch of names in it. But I grabbed a small subset of that, and we're going to use that for the purposes of this video. So I'm going to read and write with the small E22, okay? So you can see where it is in that directory, and that'll come into play in a little bit. So all I do right here is I have some comments, and then I create a string. And in that string, I give the name of the file, okay? Small E22.txt. And then I do the three things. If you've read the slides, you know the three things that are important to think about right now. You want to open your file, you want to read from your file, and then you want to close your file. So what we do right here is we run the open function on the in file, which is just that string right there. And then comma, we tell it R in single quotes. And that R stands for read. And you're going to see how that can be different later on because we're going to write to a file later. But right now we want to tell Python, hey, we're going to read from this file, okay? Set up access to the first spot in this file with a variable called F for file, okay? And then very simply, with just a variable called data, we're going to read in all of that file. That's what the .read does, okay? You're going to see that that's what we call a method later, but right now just think of it as a little mini program that we can run on our variable. You say .read, and then you can say f.close when you're done. And that's it. And then you can print your data. Now, let's get a little area so we can work. First thing I'm going to do is I'm actually going to print the data so we can see. Let's get a nice little area that we can work with here. Okay, so that's at the bottom down there. So as you can see, it read in all of that data, but it read it all into one big string. And what we do to figure that out is I do a len on the, yeah, that's all the stuff you're not supposed to see yet. Very nice. And I do a len on it, and it says 2083. Now what that is it's the number of characters, because we just ran len on a string. Okay? So right now we opened our file, we read in all the data, and we have literally all of our data sitting in a big old 2,000 character string. But we're going to change that in a second. So I'm just going to plop that out. Now we're going to grab some other code that I have waiting for us right here, and we're going to learn about cleaning our data up and getting it into a form where we can use it. The first thing we're going to do is we're going to say data is assigned data, but we're going to replace, and if you can see, it's got the double quotes inside single quotes. We're going to replace the double quotes with nothing. Just boom, boom, quote, quote, okay? And then we're going to print it, just so I can show you the intermediate stage. I'm going to Zotz that part out. So now when we run it, you can see I've gotten rid of the double quotes. So now I just have name, comma, name, comma, name, comma, name. All right? So that's the way, if you got something in your file that you want to get rid of, you do a replace, but you replace it with nothing, and then it'll get rid of it, okay? Now you're going to learn about a very special method called split. Split does something incredibly cool and incredibly useful. What you give split is what we in computer science as programming geeks call a delimiter, okay? Delimiter is just, I guess, the derivation or the etymology would be something at the end, but what it is it's something that separates. It's something that separates your data. So here, I give it the comma because, look, the comma separates all our data. So when I run the split on the data, it's going to separate all of these things out wherever there a comma is. It's not going to keep the comma, and this is the magical part. It's going to take this string, but the return value of split is a list. So now when I run both of these things, I get rid of my double quotes, and then I run a split, you're going to see when I print data, it's a list. See the bracket right there? And then it comes down here and it ends with a bracket. Now you might be saying, yeah, great, I've been printing all these names the whole time. What's the big deal? But it is a big deal. It's a huge deal now, because now I have my data in a list. And once I have my data in a list, now I can start doing things. Now I can analyze. Now I can look for different things. Okay? So, I think Jackie's the last one, so we're going to look at that in a second. But let's just pick a name out in here. Here you go. There's Sarah. So we'll do Sarah. Okay? Now that it's in a list, I can go through the code and I can look for different things. So what do I do here? I set up a counter really quick. And then I say for I and data, I don't need range. I have a list, so I can just iterate through the list. Then I start going through. I'm clicking my counter, so I'm going to count how many items I have. If this is the first time you're seeing this, take a look. It's plus equals. It basically allows you to do a counter. It's the equivalent of C equals C plus 1. Or C is assigned C plus 1. But it lets you take the extra variable mention out of there. Okay, it's a little programming shortcut. All right, so what I'm doing is I'm clicking a counter, and then I say if I, which is just a name, you can see our data right here, is equivalent to equals, okay, not assignment, but to or is equivalency. If it's equal to Sarah, which we know exists because it's right there, we're eyeballing it, print, and then print the point in the file where it is. So we're going to count those names, and when we hit Sarah, it'll print out whatever number Sarah is, and I have no idea what it is. Then we'll keep running until we get to the end, and then at the end we'll print C. And if memory serves, I think there's like 235 or something like that. So now when we run this code, we see that Sarah is the 84th item, and there are 235 names in that list. So think about it. Now we're doing something. We can take our data and look in it and find a particular name, and we did, and we were able to print out what spot it appears in, and we were able to count up all our data, right? Okay? Yeah, I didn't do this, but should I? If I come here and I take this print data and I don't print the list, I do a len on it. I should have done this before. You see I get 235 because now it's doing a len on the list. And if you do a len on a list, it tells you how many items are in the list. Okay? So I know now I'm good. I don't have that string anymore. I have the list, which I can now use. And as you can see, I can use for real stuff. All right, because we run that. Tells me where Sarah is now. I know the last, let me stretch this out a little bit. The last item is called Jackie. So what I usually do is we'll go look for Jackie. And what happens is Jackie's the last item. So it says Jackie 235 and then 235. We know things are working pretty well when we can pull that off. Okay? So now we've read in our file. We've cleaned the data a little bit. We've gotten rid of the double quotes. We got it in a form where we can use it, which is a list, and then we've iterated through it. And we're searching for different names, and we're counting up how many there are, and we're doing a lot of different interesting stuff, okay? Seems simple, but this is the beginning of analysis. This is the beginning of looking at your data, you know, picking things out by criteria and doing different things with it, okay? I am going to get rid of this. And do I want to keep that? Yeah, I think I do, because I'm going to come down here and we're going to play around with this piece of code right here. And I think, yeah, we basically got two more things that we need to do. All right. This next part, I'm going to come back out here and I'm going to show you the files. I have a file called numbers2. And as you can see, numbers2.dat is just 12, 23, 34. It's just a file with some numbers in it, line by line, okay? And it resides in the same directory where I have our program, which is file stuff, all right? All right, you know that. Now, this is something different. This is called the with construct. And as we use a with, we say with, and then we run our open command, just like it was at the top here, just like our open up here. We run the open for the file, only in this case I'm opening numbers2.dat, R for reading, and I say as F. So I'm going to, you know, my pointer to that is still going to be F because F is kind of going to be my variable. But now I jump into an iterative loop and I say for line, line is just a variable. Like I say in the past, it could be Fred, it could be dog, it could be anything. I say line because it makes sense when you read it. Readability is a big thing with Python code. So I try to make it readable so that a programmer reading this understands what's going on. And it's important for you to understand that too, obviously, because you're learning all this stuff. coffee break. All right, so then I say for line in F, and then I print the integer version of line. So I cast the thing. But line, as it comes in one by one, as you can see, first it's going to get 12, then it's going to get 23, then it's going to get 34, okay? Now I do the integer when I can print it. You're going to see what that's about in a little bit. So now when I run this piece of code, you'll see it prints the file. I get 12, 23, 34, 45, because that's exactly what I told it to do. Now, take a look at those 3 lines of code. Do you see a read statement? No, the read is kind of understood. Do you see a close? No, you don't see the close, but it does close. These things happen not explicitly, but implicitly. You gotta, when you learn more about Python, you're gonna learn that different structures can work with a with as, and when you create them, you're going to create a data type. This data type is a file, but you're going to create data types that can work with as, and you will define what it can do when it does it. So this is defined so that when it deals with files and goes into an iteration like this, it reads line by line without you having to say read. And then when that loop is ended, it automatically closes for you. All right? I'm not doing this to confuse you. I am not doing this because I think it's necessarily the best thing in the world to see right now when you're learning how to do this. The reason I am showing you this is because everybody in the world uses it. When you look at Python code, be it a third-party library, be it some example on the web, be it something to do with file I/O, you're gonna see it done this way. Because a lot of data comes in when we read it line by line. And when you read data line by line like this, where you want to set up a loop, read your data, do something, read the next line, do something, read the next line, do something, you're going to use a with as structure. So I want you to see it. You know, at the end of the day, I want you to be a Python programmer. So you're going to see this particular construct. You're going to see it out there because it's used all over the place. And it's going to become second nature to you, and you're actually going to start using it, and you're going to do some different things. When you do file I/O for your different assignments and different things that you have to do in Unit 3, if you want to use this, that's fine with me. I don't care. Or you could do it the other way. You could read it into a string, clean up your data, do whatever you want to do that way. It's fine. I just want you to see this because every Python programmer on the planet uses it. I use it. So you should see it. You should know what's going on with it. I want you to see the real way to do things like open, read, close, so you understand that's still going on there. It's just happening in the background. Okay? You're kind of opening it explicitly when you define the with. But the read happens without you having to say read, and the close happens at the end of the loop. All right? All right, enough said. We got one more thing we need to do, but it's pretty interesting and it's pretty important, so this should be cool. Again, I say it all the time, you don't have to type this code in. I'm going to throw it up on Canvas for you. All right? All right. I'm going to use numbers2.dat, which you're familiar with, so this will be a good thing. But this is the part of our show where we deal with output files. So I'm not just going to have a file that I'm reading my data in from. I also want to have a file that I'm writing my data out to. Okay, so I'm just going to create it. I have the incredibly creative variable name of OF for output file, I'm assuming, and I assign it the open of something new. I call it outnums.dat. That file does not exist. Okay, we're going to be creating it. If you can see that list of files right there, that file does not exist. We're going to create it, and as I alluded to before, we're not going to have the R up there for reading. We're going to give it a W for writing because we're going to create an output file and we're going to write things to this file. Okay? Instead of reading things in, we're going to write things out to this file. Now, the same as our with construct up here, I'm going to say with open numbers2 as F. So I'm reading in my numbers file, my numbers2 file, which is 12, 23, 34, whatever it is. Okay? Now I jump into my loop for line in F. And like we did before up here, I print the line, but now I'm doing something different. In this second line, I create a variable called bump. And what bump is it's the integer line plus 1. So if I read in that 12, it's going to become 13. If I read in that 23, it's going to become 24, right? Then in this line, I write it to the output file. You see I have OF. Instead of .read, now I have .write. So my output file, which is tied to outnums.dat, I write. Now remember, bump is an integer. This is sequential character data though. So I want to make sure I'm writing a string. We always have to write strings to sequential files. All right? So I take the bump variable, which is 13 in the first instance. I create a string with it and I write it to the file. But I also concatenate or append a \n because I want the format to be the same as my input file. So I want to make sure I get a fresh new line for the next time I write. If we just wrote the numbers, it would be all in a row. We may even do that real quick if we want to do that. Okay? Then it comes up and gets the next line. What's the next line? 23. Come down here, print 23. Bump, int line, 23 plus 1 is 24. Write the string version of 24 in a new line, so it writes 24. All right? We're going to run this piece of code here. And it's not going to work. Well, I'm going to show you why in a second. We're going to run this right now. So we run that code, and just like the previous try up here, we do print it out. So now I come here to my file listing, and lo and behold, I have outnums right there, which is pretty good. All right, I'm in good shape except for one thing. And I'm sure we're zooming in on that guy. There's nothing there. It's a blank file. So something went haywire here. All right, I'm going to delete this because I know I'm going to come create it again. The Python program, didn't it? Well, it'll overwrite it. Let me leave it down. All right, so I come down here and I see that what I didn't do, and why I have it there marked off, is I didn't close my file. If you read in a file and then you have your data and you forget to close it, it's not the biggest deal in the world, because it used to be a big deal when I was a kid because memory was precious, so you couldn't leave your files open. Plus, if you were in a mainframe setting where a lot of different people were trying to get to different resources, you would lock it up so that other people couldn't get to it. So you really got it ingrained in your head that get in, get your data, close the file, and get out, okay? Nowadays, we're lousy with memory. A lot of people are just working on their machines, so there's no real price to pay for not closing your files. Here, though, we're dealing with an output file. There's a price to pay. When you write that file, when this little program is going through its loop and writing to outnums, it's not writing everything to the hard drive every time. What it's doing is it's writing it in a little temporary area in memory. And that little temporary area in memory is not going to get written to the hard drive and become a real file until you close. Until you close the output file. Remember, because the output file isn't part of our little with as construct here. It's done in the first line. So that's a regular file open. You've got to remember to close, because what you're going to do is you're going to have that temporary memory area and you're going to want to write it to the hard drive to get your file. So now that I have that close statement there, I rerun our code. The same thing happens down here, but now when I come back here, outnums all of a sudden has some meat to its bones. It's got one, and you can see now there is an actual file, and if you line it up right here, you can see that it is one more than the original file, because as we came through, we read it, we bumped it up one, and then we rewrote it, and we got a file with the same format as we did with our other file there. But we had to remember to close. You had to be a good citizen, because until you close, you're not going to take that temporary area and write it down to the hard drive. Okay? All right, so this was the file I/O video. All right? Remember that basic, am I going to run a grand finale with the file I/O? What happens when we do that? All right, everything runs pretty good, and then we come here and we get outnums again. We do get outnums again. All right. So we don't need that, we don't need that, we don't need that. We will leave that down there. Remember, file I/O, especially in this simple sense, is just read, well, open, then read your data in, and then get out of Dodge and make sure you close your file. Then you can do whatever you want with your data. In this case, we cleaned it up a little bit. We got rid of the double quotes, and then we split it up so we could get it in a list. And the minute it's in a list, then we can iterate over it. And the minute you can iterate over something, then you can start examining things and looking for things and adding them up, counting them, looking for specific items that meet certain criteria. We could do all of that neat stuff. We looked at the with as construct. If for no other reason, because you're going to see it from now until you are not a Python programmer anymore, which is hopefully a long time from now. All right, the with as is used quite often, especially in file processing when you go line by line by line by line by line. Okay, and then really quick, we took a look at some output file stuff. Output's easy. Just think of it as the opposite of the input thing. You're now taking your data and writing it out. You're writing it out to that file. But in our instance right here, we're using sequential files, so you want to make sure it's a character. So when you read it in, it's going to be a character. You got to turn it into an integer to do math stuff with it. Then you want to turn it back into a string when you write it. All right, and if you want to have a decent file format and make things look nice, you're going to want to shoot that new line in there, like you all learned with the extra credit in the previous unit. All right? All right. Then I'm going to get out of here because this is a generic, and we're going to have more videos with announcements and different things coming on down the line. But this is the second review video for Unit 3, and in the past, that was it. But Unit 3, remember, is a 3-week sequence. So there's going to be a third video coming down the pike where we're going to talk about libraries, and we're going to talk about modularity, and we're going to learn about doing our own libraries. Then there's going to be an example video where we do a little quick homework assignment that resembles the homework assignment for Unit 3, so you get your sea legs a little bit as far as that's concerned. And then we're going to have a cool video where we're going to rewrite Euler 6, and we're going to do it with functions. And we're going to do it with these things called list comprehensions and have a little bit of fun and play some games with Python. All right? All right, then I'm going to get out of here. You be good, and I'll see you for the third video in a couple of days.